Hello and welcome to this first demonstration on using voice activation or natural language processing to control your IoT devices. In this specific video, I'm going to be giving you a short demonstration of some of the things that you can do. This won't be a detail on how to build these things. There'll be videos that follow from this video that'll go into the details of the various different aspects of the programming and the design and architecture of such a device and the ecosystem behind the device. So this is the thermostat, this PCB here, and I'll make these PCBs available. Information on that will be following in other videos. In this specific case, I'm using the Particle Photon microcontroller, and then this PCB actually has these 5 wires that go into your home's wiring. So the existing thermostat's wiring is essentially what's being used here, and this board is powered by the wiring from the house, as well as it has 3 wires that go. So there's totally 5 wires, of which 2 are for the power supply. This is an AC 24-volt power supply, and then the 3 wires, 1 for the fan, 1 for the AC, and 1 for the heater. This board over here, the bulbs, I'm just trying to emulate the HVAC unit that you would have at home, so that I can have this demonstration going on here without actually turning on the heater or the AC or something while the demo is going on. So on the screen here, you're seeing a phone application. This is the phone application, and that's the kind of the architecture, if you will, of the entire ecosystem. So you got the main device, which is the PCB here. Then you got the phone app, which is this guy here. You got an MQTT broker, which is like a pub sub broker. MQTT is a very, very lightweight protocol that's used by these constrained devices, meaning devices that don't have a whole lot of CPU and memory available to them. It's a very, very fast protocol because it's so lightweight. It's like, I think it's 2 bytes more than the actual data that you send across the wire. So if you wanted, you could use MQTT for regular applications instead of something like RabbitMQ or Service Bus and other pub sub brokers. But there's a whole ecosystem behind the scenes, which we'll get into much more detail in later videos. In this video, I just want to give you this demonstration, primarily showing you how to use natural language processing to control IoT devices. Well, I'm not going to show you how to do that. I'm showing you the demo of it working, and then in later videos, we'll go into the details of all of the programming and the setup and stuff like that. So what you're seeing here is the settings. In this case, the mode is set to off. It can have a value of heat, cool, or fan. The zones are in number. You can simply just plug in a device somewhere and give it a name, and it'll just show up here. And then you can use that device's temperature as the settings for your thermostat. So in this case, the hardware along with the software is a multi-zone thermostat. So you can set the thermostat to any one of these zones and control the temperature based on the temperature in that zone. You can set the temperature to whatever you want here. At this point, it's set to 80. Probably not the right temperature, but for this demo, it'll work. The temperature here is the temperature of the zone. In this case, is the study. So that's the temperature in the study. And these are the other zones and their temperature and humidity. Of course, some of them don't have, like the study doesn't have a humidity sensor. It's just got a temperature sensor. Whereas the master bedroom and the family room have a humidity sensor as well, because that's where humidity is more important. Not that it controls the humidity, but it's nice to see what the humidity is. The sensor here is a the temperature, humidity, and pressure sensor all in one. The board allows you to control or to hook up through the I2C bus other sensors or an OLED display and a bunch of other ancillary sensors and devices that function off of the I2C bus. But I don't need an OLED display here since I got this phone application. And for the most part, I'm not so interested in seeing information as much as I'm interested in controlling the thermostat. But through the voice activation or the natural language processing, you can also ask her, I'll say her instead of the name, information on the device. So let's get started with the actual demo. Remember, this is not going to show you how to do something, it's just more about showing you what can be done. And I'll explain some of the stuff as it goes along. So in Alexa, oops, shouldn't have taken a name there. You have something called intents. So you can see here, and this is my dashboard, Amazon Alexa dashboard. You can see there are 10 custom intents. There are 4 custom slots, and I'll explain what these are just at a high level. So intents are the sort of the operations that you want to have. Like I've got this intent that says get temperature in zone intent. In other words, I can ask her to get me a temperature in a specific zone, or get temperature settings intent. So I can ask her to give me these settings, and so on. And then the slots are sort of the parameters or the placeholders for when you say something like get me the temperature in the study being a placeholder. It could be any one of the other zones, and that's a slot. They call it a slot. So you have to kind of build up this model of the different intents and then the different utterances within the intent. For example, if I look at the turn appliance on or off intent, you can see the different utterances I have here. So you could say things like turn on or off some appliance. So remember, see this is the turn blah the blah, then turn blah blah, so you don't have the in the middle. And switch on or off the appliance, switch on off appliance, turn the appliance on or off, turn appliance on or off, switch appliance on or off. So these are the different utterances, and within these utterances there are these slots that each have possible values if you want to kind of constrain that. It doesn't have to be, but there's in this case it's on and off would have 2 possible options, on or off. The appliance is a slot that has a possible set of appliances like the different zones, and the temperature is just a number, so it can take on any number. So I could also say turn on or off the appliance at this temperature in this zone. So these are the different utterances for the one intent. Each intent has multiple utterances to try and keep this conversation more natural. You have to sort of think about the different possible ways in which somebody would want to interact with the device, and then you would have to have these utterances to support those different interactions. Right? So that's at a high level, that's how you would set up Alexa. Of course, there's some programming behind the scenes, not here, but in the Azure, the Lambda function. You could use Azure, so Alexa can talk to an Azure function, or it can talk to Amazon Lambda. I'm using Lambda, but I could have used an Azure function as well. It just needs to be an HTTPS endpoint for you to be able to set it up in Alexa to talk to that endpoint. The device, the main device, which is the thermostat device, and all other remote devices are essentially talking to this MQTT broker, so they don't know of each other's existence. The broker is the kind of the broker. Basically, everything talks and works through the broker. They don't know of each other. The UWP application also talks to the broker, and the Amazon Lambda function also talks to the broker. So there's no direct communication between devices and other things. Each device or each thing just knows about the broker. The broker is the kind of the common aspect. The Azure worker role is also a subscriber to the various topics, and I'll show what this is being used for. Essentially, besides some logging, I won't call it logging, it's quite extensive, the data that's being persisted to Azure table storage, but I can then pull up reports and a bunch of other things to tell me how long things have been on or off, or what the temperatures have been. While the temperature in the master bedroom is this, what's the temperature been in the family room or outside or whatever. So, but don't want to get caught up in all the details, because at the basic level, you need this thermostat board, you need a broker, and you need some application, something that can send messages to various topics here so that the device can react to that. The rest of the stuff is just sort of additional ancillary stuff that gives you more capabilities, including the natural language processing feature. So let's get back to the Alexa side now. So I could say, Alexa, ask thermostat for settings.
The current zone is steady. The temperature is set to 80. The mode is off, and the heating and air conditioning is off.
There's a little orange light that lights up here to indicate whether the heater or the air conditioner is currently on, and so she's reading that. And of course, of the three bulbs here, one of them will be turned on if an appliance was on. So I could say something like, Alexa, ask thermostat to turn on the fan. And see the light.
I've turned on the fan.
So the light came on here, and the mode switched to fan, and then this light came on here, and then this event came up here. So a bunch of things happened with that one command. Essentially, the fan came on, so that's the physical sort of the fan that came on. Each time Alexa confirms that she's done something, that implies it was successful, as in she's not just assuming it's a success. By the time she tells you it was successful, the actual device has received that message. The phone application and the notification happens a few seconds later. So that's just because I've decided that all these devices publish their messages once every 5 seconds. So I don't need that instantaneous, real-time kind of response. So by the time you hear her saying she's turned something on, the UI may not have shown it right away. It takes about 5 seconds at most to reflect the change. Alexa, ask thermostat to turn off the fan.
I've set the thermostat mode to off.
And the fan's gone off, and that's gone off. And then they get notification. So you could query other information. You could say, Alexa, ask thermostat for the temperature in the master bedroom.
It is 78.91 degrees in the master bedroom, and the humidity is 53.24%.
You could ask her for what I call status, which is the whole thing, all this information. Alexa, ask thermostat for status.
The current zone is steady. The temperature is set to 80. The mode is off, and the heating and air conditioning is off. It is 78.91 degrees in the master bedroom, and the humidity is 53.09%. It is 84.65 degrees in the family room, and the humidity is 42.11%. It is 76.78 degrees in the living room, and the humidity is 0%. It is 71.37 degrees in the study, and the humidity is 0%.
Of course, this could get pretty tedious to sit and wait for all these things, especially if the one you're interested in comes in last. And of course, sometimes you've kind of got your information as soon as it's kind of gone by. So you can stop Alexa in the middle. And I'll do this again so I can show you how that works. Alexa, ask thermostat for status.
The current zone is steady.
So she's going to go through all of this. I'm going to ask her to stop now. Alexa, stop. So I find you got to be a little authoritative in the way you say that, and probably also have to be speaking a little louder so she can hear you over herself, if you will. but that's not something you have to program specifically, but you do have to account for certain best practices in the Alexa SDK for you to then make this work across all your intents. Alexa, ask thermostat for temperature in the master bedroom.
It is 78.94 degrees in the master bedroom, and the humidity is 53.36%.
Right, so of course this is a little different from here because she's seeing the sort of the later information, whereas here you're seeing the last within that 5-second range. So it does change quite a bit. Now, if you want to turn on, let's say the air conditioner or something, then you can just say that. You can also just turn on or sort of change the temperature, change just the zone, etc. So let me show you that. Alexa, ask thermostat to set the temperature to 67.
I've set the thermostat temperature to 67.
There you go. Now you may be sitting there, let's say the heater is on, and you don't necessarily know the temperature, but you know it's not warm enough, let's say, in winter. So you know if you just jacked up the temperature by a couple of degrees or so, it should be fine. So you could say something like, Alexa, ask thermostat to dial it up by 2 degrees.
I've increased the temperature by 2 degrees.
So it should become 69. There you go. And of course, that's just something I've programmed it, one of the utterances that I've defined. You could actually say increase and decrease, but sometimes the increase, decrease is not easily distinguishable depending on who's talking. So I decided, use a little bit of slang, say dial it up or turn it up or something. I think I've also done turn it up. Alexa, ask thermostat to turn it up by 2 degrees.
I've increased the temperature by 2 degrees.
Right, so she understands, turn it up. Alexa, ask thermostat to dial it down by 4 degrees.
I've decreased the temperature by 4 degrees.
Right. So now that the temperature has been set to 67, and the temperature in this case, the study is 71, if I were to turn on the air conditioner, the actual air conditioner would turn on. In other words, if you tell her to turn on the air conditioner, she just sets the mode to cool. The thermostat here, this device, has got its own brain, and so it knows that, you set the mode to cool, you set the temperature to 67, but the room is, let's say, 66, so I'm not going to actually turn on the air conditioner. Even though I've been set to the mode of cool, I won't actually do it. Alexa doesn't know that. That's controlled by the logic here in the actual device. So I could, now because the temperature is much higher, if I turn on the air conditioner, you'll see her telling you she's turned on the air conditioner. A few things will happen. The AC light should turn on. The mode should switch to cool, and then the orange light here in the screen on the application should also turn on. Alexa, ask thermostat to turn on the air conditioner.
I've turned on the air conditioner.
You'll see the light come on. This change to cool, and this light comes on. And of course, this other notification comes on as well, because this notification comes every time the appliance changes state. So either the heater goes from off to on or on to off, or the air conditioner goes from off to on or on to off, or the fan goes on to off or off to on. That's just, again, programming that I've done to get notification, but I also get a sense of how long something's been on or off. I'm also logging that so I can get a bunch of reports to see how often the AC comes on or stays on, and how long it goes off for, and I can do some math and figure out the efficiencies I'm able to get from this multi-zone thermostat, which is actually pretty real. I found that at night, when we have the AC on in the master bedroom, it's on for, once it's got to a specific temperature, so once unless you let the temperature go on up to about 80 degrees during the day, once it's cooled down the room, through the night it really stays on for probably 2 minutes and stays off for anywhere from 9 minutes to 16 minutes, sometimes even half an hour, probably depending on the outside temperature. So the AC just comes on for like 2 minutes to keep the room temperature at 67, and then it goes off for 18 minutes or 12 minutes at a time. I think that's pretty cool, because if you were to cool down the entire house, that would cost you quite a bit more. Now, if you don't know what the settings are and you want to turn on the air conditioner and set the zone to the master bedroom and let's say change the temperature to something else, or whatever it is, you don't know what the temperature is, you could say it like this. Let me first turn off the, not that you have to, but just so you can see it all happen again. Alexa, ask thermostat to turn off the air conditioner.
I've set the thermostat mode to off.
And these two go off and the notification comes in. Okay. So now I want to change the zone to master bedroom. Let's say I'll set the temperature to 67 and I want to turn on the air conditioner all in one instruction. Alexa, ask thermostat to turn on the air conditioner at 66 in the master bedroom.
I've turned on the air conditioner at 66 in the master bedroom.
So you'll see the light come on here and mode change to cool. The zone changed to master bedroom. The temperature got set to 66 and the light came on and that notification came in. So there's a bunch of different ways in which you can interact with the voice side of things. The thermostat itself doesn't know anything about voice. It just understands basic instruction by way of MQTT messages appearing on a specific topic. The interesting thing in all of this was that I didn't have to actually didn't have to do anything special, any programming for the thermostat. Of course, you had to design the messaging between the devices or your application and the device correctly. But I had actually done that well before I decided to use any voice-activated technology. And I found that I didn't have to do anything on the actual device to reprogram it or change something about it in order to support the natural language processing aspect. The key aspect, of course, is this broker. If I hadn't used the broker to publish and subscribe to events across these different devices, things would have been quite a bit harder. So MQTT was, or any broker for that matter, was instrumental in making everything kind of decoupled, and therefore everything just works just because no one device knows of the other device's existence. You can have an application you build using C#.NET on the desktop that is either publishing messages for this thing to react to or receiving messages from all other devices and showing that up. So the device per se doesn't really care that that's an IoT device that's talking to me or not. It doesn't know these devices. It doesn't know the application. It doesn't know Echo. It doesn't know anything, right? So this device again works pretty much all by itself with the hardware and the programming and the wiring from the house. At the very least, you need this device and a phone application or something that can send messages to the broker so that the device can respond to instruction such as change the setting or whatever. Right? So that's the bare minimum. The rest of it is ancillary. So I hope this gives you a good idea of not only an IoT device or a useful IoT device and the kinds of things you could do at the IoT level, but also with some of the infrastructure here, Azure, Amazon, natural language processing, and a bunch of other stuff that helps put this entire ecosystem in place so that it now becomes a very useful and viable product or a viable device. And in the next videos, in the forthcoming videos, I'll be going into the details of each of the different aspects of this ecosystem. There's a bunch of languages in play, a bunch of IDEs or platforms in play, and a bunch of cloud services in play. So there's a lot that goes on here. C++ on the devices, C# for the UWP application, C++ again for these devices, Node.js for the Lambda function. Didn't have to be Node.js, but in this case it is. It could have been C#, except that I don't like the SDK they provided for the Alexa aspects. It's pretty lame, I think. On the Azure side, if I were to use Azure functions, I'd be able to use the same code that I have here, the Node.js code, and run it on Azure function instead. And then there's of course the C# application here for the worker role, and the notification hub was the same C# application. So C, C++, C#, Node.js, TypeScript, and a bunch of different IDEs to get it all working. So let me know if you like this video, and if you want to see the details of how to build not just the thermostat, but other devices that I plan to have. If you're interested in knowing the details or just seeing demo videos, let me know and I'll plan accordingly. I am actually planning to make detailed videos on these devices, on the electronic side of things, on the programming side of things, the PCB and the layout for these things, etc. So hope you liked it, and let me know what you'd like to see. Thank you.